and inconsistency of system of linear equations. Okay. So a system is consistent if it has at least one solution. So if system of equations are given to you, it will be termed as consistent if it has at least one solution. Okay? If it has at least one solution. And a system is called inconsistent if it has no solution. So a system will be termed as inconsistent or consistent depending upon whether it has solution, at least one solution, or inconsistent if it has no solution. Let us understand with the examples. So example is x plus 2y is equal to 5 and 2x plus 4y is equal to 10. What is the solution of this equation? X equal to 5 and y equal to 0. Isn't it? So it has at least one solution, therefore it is consistent. But look at this particular problem, and 2x plus 4y is equal to 9. Does this system has any solution? It does not contain any solution. Okay, because if it were to have if it was to have consistency, it should have been 10. If it is not, obviously it is not going to be a consistent solution. It has no solution, in fact. So it has no solution. Therefore the system is inconsistent. ये समझ में आ गया सबको?
Yes, sir.
Yes, sir.
All right. Now, what about the homogeneous system? The homogeneous system is always consistent. Why? Because it has a trivial solution always. 0, 0, 0 will always be there. Is it or not?
Yes, sir.
So therefore it is always consistent. So homogeneous के केस में नहीं है ये अप्लाई होगा किस केस में?
Non-homogeneous.
नॉन होमोजीनियस के केस में. ओके, समझ में आ गया सबको?
Yes, sir.
Up there are a couple of theorems which we are going to talk about. So theorem number 1. This theorem talks about on the consistency of non-homogeneous system. So we have a non-homogeneous system. Let us say A11, X1, A12, X2, and so on and so forth. A1n, Xn is equal to B1. A21, X1, A22, X2, A2n, Xn is equal to B2. Okay. Like that, actually, if we consider that a m1 x1, m2 x2, and a mn xn is equal to bn, we have a system. How many equations are there? M equations. How many unknowns are there? N unknowns. Okay, this is system of equations. Okay, now we consider, we can write down this whole thing in matrix form. How can we write down in matrix form? We can write down a matrix A. Matrix A is A11, A12, A1n, A21, A22, like that, A2n, and so on and so forth. So the last equation will be AM2, AMN. Okay? And another matrix we can write down. A11, A12, A1, A1 and B1. Now we are including the right hand side also. A21, A22, A2n, B2, and so on and so forth. So the last equation will be AM1, M2, AMN, BN. Okay? The last equation will be this. Now just see that this A is submatrix of B, isn't it?
Yes, sir.
A is submatrix of B. This matrix is known as coefficient matrix. And this matrix is known as augmented matrix. AUGMENTED, augmented matrix. Okay? So now we just see over here, or I should write down BM actually, because M equations I am writing BM. Okay, so this is what we will get. Fine. Now there are three things which we need to remember for the consistency of non-homogeneous equations. Has everybody written down all these things?
Yes, sir.
So number one thing is that the system is consistent if and only if that rank of A is equal to rank of B. Number one, that the system is consistent only and only if rank of A is equal to rank of B. तो augmented matrix का जो rank है, the same should be the rank of coefficient matrix. If it is not, it is inconsistent. So number one thing is this. Number second thing is that if it is consistent, है ना? If it is consistent, then in that case, it has unique solution. If rank of A is equal to number of unknown. Okay, the system is consistent if and only if that rank of A is equal to rank of B. Second thing, that if the system is consistent, that is rank of A is equal to rank of B, then in that case, it will have unique solution only and only if that rank of A is equal to number of unknowns. So number of unknowns should be equal to rank of A. If it is not, it will not have unique solution. I hope it is clear. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. And number third thing is this. Number third thing is that the consistent system has many solutions. If rank of A is less than number of unknown. All right. These three things we must remember on the consistency of non-homogeneous equations. That if rank of A is equal to rank of B, then only the system is consistent. If rank of A, if the system is consistent, then rank of A should be equal to number of unknowns. Then it has unique solution. That is only one solution it will have, right? And if the system is consistent, but rank of A is less than number of unknowns, then it has many solutions. Then it has many solutions. That I forgot to write. Okay? Then it has many solutions. Not only one, there will be more than one solutions will be there. I hope it is clear.
Yes, sir.
Yes, sir.
All right. Now comes another theorem. That on the existence of non-trivial solution of unknown of homogeneous actually.
सर
हाँ बोलो
सर रैंक ऑफ ए अगर ग्रेटर देन होगा तो
क्या होगा
नो सॉल्यूशन
हो सकता है क्या रैंक
ग्रेटर
ऑफ
हो नहीं सकता सर।
हाँ फिर
ओके सर
हाँ ग्रेटर हो नहीं सकता ना अंडरस्टैंड
यस सर
So that is one. So on the existence of non-trivial solution of homogeneous systems. So what are your homogeneous system? A11, x1, 1, 2, x2, and so on and so forth. 1n, xn is equal to b1. A21, x1, A22, x2, and A2n, xn is equal to b2. And like that, AM1, x1, AM2, x2, amn, xn is equal to bm. Okay, m equations है ना तो let us take m. Wherever bn is there, you can make it bm. Right? अब b1 and b2 sorry, not b की तो जरूरत नहीं है. Sorry, I forgot to. This should be equal to 0. क्या homogeneous system है ना? So this should be equal to 0. Please put 0 everywhere. So now this is the thing. तो हमारे पास जो कोफिशिएंट मैट्रिक्स है वो क्या होगा इस केस में A11, A12, A1n, A21, A22, A2n, and finally AM1, AM2, Mn. Is it okay?
Yes, sir.
All right. Now the thing is that this system has non-trivial solutions. मतलब non-trivial solution का क्या मतलब है? The solution other than 0, 0, 0, 0, 0. Correct. 0, 0, 0. The system has non-trivial solution only if rank of A is less than number of, ठीक है ना? ये जो कोफिशिएंट मैट्रिक्स है इसका रैंक हमेशा नंबर ऑफ अननोन से कम होना चाहिए, तभी सिस्टम है जो है उसमें उसका नॉन ट्रिवियल सॉल्यूशन होगा. अदरवाइज क्या होगा? 0, 0, 0 तो हमेशा सॉल्यूशन है, तो सिस्टम इज ऑलवेज कंसिस्टेंट एंड द सॉल्यूशन इज 0, 0, 0. आई होप इट इज क्लियर.
Yes, sir.
Yes, sir.
Yeah. All right. So now let us do some problems.
Yes, sir.
यहां तक सबको समझ में आ गया? Has everybody understood up to this point?
Yes, sir.
तो हमको एग्जामिन करना है, एक सिस्टम है x1 प्लस, लिखना है x1 प्लस 2x2 माइनस x3 इज इक्वल टू 3, 3x1 माइनस x2 प्लस 2x3 इज इक्वल टू 1, 2x1 minus 2x2 plus 3x3 is equal to 2, x1 minus x2 plus x3 is equal to minus 1. Right? All right?
Yes, sir.
This is system of equation. Yes, sir. तो अब इसमें कोफिशिएंट मैट्रिक्स क्या होगा बताओ? 1, 2, minus 1, 3, minus 1, 2, 2, minus 2, 3, and 1, minus 1, 1. Is it okay?
Yes, sir.
sir. And augmented matrix क्या होगा? 1, 2, minus 1, 3, 3, minus 1, 2, 1, 2 minus 2, 3, 2, and 1 minus 1, 1 minus 1. यही होगा ना?
Yes, sir.
Right?
Yes, sir.
अब हम यदि एलिमेंट्री रो ऑपरेशन बी पे लगाएंगे तो ऑटोमेटिकली इट विल अप्लाई ऑन ए ऑल्सो, बिकॉज ए इज सब मैट्रिक्स ऑफ बी. इज इट और नॉट?
Yes, sir.
आर यू गेटिंग माय पॉइंट?
Sir, no, sir. Repeat again.
हाँ, this is submatrix of B.
Yes, sir.
So if I apply any row operations here, then that will apply here also on this submatrix also,
Okay, sir.
right?
Yes, sir.
So that is what I want to say. So let us apply on B the row operations. Okay, elementary row operations. So first of all, let me apply R2 minus. So what we have to check whether this system of equations are consistent or not. We have to check the consistency of the system. Okay, I forgot to mention. This is what is our aim. Okay. So now R2 minus 3R1 will be 1, 2, minus 1, 3, 0, minus 7, 5, minus 8, 2, minus 2, 3, 2, 1, minus 1, 1, minus 1. All right. So this is the first operation we have to do. First, in order to, we have to convert this into echelon form. That is our aim. We have to convert it into echelon form. Okay. So now, first of all, what we want that these all should become 0. First row में जो first pivot है, remaining that all the other elements should become 0. So we have to make it operation like that. So then R3 minus 2R1. All right. So R3 minus 2R1 is 1, 2 minus 1, 3. Then 0 minus 7, 5 minus 8. Okay. Then 0 minus 6, 5 minus 4, and 1 minus 1, 1 minus 1. So now we have got rid of 2 from the first column. Third row, first column. Okay. Now we have to make this as 0. So it means that R4 minus R1. So when we do that, it is 1, 2 minus 1, 3. 0 minus 7, 5 minus 8. 0 minus 6, 5 minus 4. 0. Then क्या आएगा? Minus 3, 2 and minus 4. Is it okay? तो we have got rid of this. अब हमको आगे इसको इक्विवेलेंट फॉर्म में लाने के लिए क्या करना पड़ेगा? सेकेंड कॉलम से हमको यहां से और ये इसको 0 लाना पड़ेगा. That is what it was. Is it or not?
Yes, sir.
Okay. So now that is what we are going to do. So R3 minus 6 by 7 R2. ठीक है? Let me operate it. So 1, 2 minus 1, 3. We have got this. Then 0 minus 7, 5 minus 8. Then 0, 0, 5 by 7, 20 by 7. And finally 0 minus 3, 2 minus 4. I hope it is clear. Clear?
Yes, sir.
All right.
Yes, sir.
All right. So we have got this. So now we have to got rid of this minus 3. In order to do that, what I have to do? R4 minus 3 by 7 R. If I do so, then what I will get? 1, 2 minus 1, 3. 0 minus 7, 5 minus 8. 0, 0, 5 by 7, 20 by 7. And this will be 0. This will be 0. This will be minus 1 by 7 and this will be minus 4 by 7. ठीक है? Is it okay?
Yes, sir.
Yes, sir.
All right. So we have got this. Now what we will do that we will multiply in R3 by 7 and R4 by 7. These two operations we will do so that this 7 will be removed. So 1, 2 minus 1, 3. 0 minus 7, 5 minus 8. 0, 0, 5, 20 and 0, 0 minus 1 minus 4. I hope it is clear.
Yes, sir.
Now we have to make we have to make 0 0 from this one. Okay, so in order to do that, R4 plus 1 by 5 R3. So we will get 1 2 minus 1 3, 0 minus 7 5 minus 8, 0 0 5 20 and 0 0 0 0. ठीक है ना?
Yes,
Is
sir.
it okay? Let me consider that
Yes,
this
sir.
is equal to matrix C. This is C matrix. Huh? Now the point is that this C matrix has come from which matrix? B matrix.
Yes, sir.
Right. So these two should be equivalent.
Yes, sir.
Okay. So matrix B and matrix C are equivalent. That from that theorem which we discussed yesterday. Huh? That these will be equivalent. Now, if they are if they are equivalent matrix, so from that theorem I say that if these two matrices are equivalent, then in that case, whatever will be the rank of this shall be the rank of this.
3,
Is it
sir.
or not? Is it or not?
Yes, sir.
And what is the rank of C?
3, sir.
3.
I'll write down. Rank of C is 3. So it means rank of B is also 3. I hope it is clear now.
Yes, sir.
Okay. Now the thing is that I have to see that what is the relation of rank of A with rank of B. In order to do so, in rank of coefficient matrix, if you recall, this particular column is not there. The last column. This column is missing there. Is it or not?
Yes, sir.
So in order to do so, what I need to do, I will have to remove one column. So that 1 2 minus 1, 0 minus 7 5, 0 0 5 and 0 0 0. ठीक है? Let me say that this is matrix D. Right? Now matrix D and matrix A are equivalent matrix. Isn't it?
Yes, sir.
Matrix D is equal to matrix A. ठीक है ना? They are equivalent. I'll write down equivalency sign like this. They are they're equivalent. Okay? Fine? So now it means that whatever will be the rank of D should be the rank of A from the theorem. Am I right? Am I right?
Yes, sir.
All right. So it means that rank of D is how much?
3, sir.
Correct. Rank of D is 3. So it means rank of A should be equal to 3. Right?
Yes,
So
sir.
now we see that rank of B is 3 and rank of A is 3. So it means rank of A is equal to rank of B. Right? Right?
Yes, sir.
So it means the system is
Consistent.
consistent. तो ये तो हमने प्रूव कर दिया कि the system is consistent. Okay. Now we have found out that system is consistent. But what we say that this rank of A is 3, and what are the number of unknowns are how many?
3, sir.
3. Correct. Okay, so number of unknowns are also 3, isn't it? x1, x2 and x3, right? So number of unknowns are also 3. Both are 3. So it means the system should have
Unique solutions.
unique solution, correct? So system will have unique solution, means it will have only
One solution.
one solution. Up to this, if anybody couldn't understand, please let me know. समझ में आ गया सबको?
सर
Yes, sir.
हाँ बोलो.
सर नंबर ऑफ अननोन 3 कैसे?
देखो ना इक्वेशन क्या दिया हुआ है. जस्ट चेक आउट योर इक्वेशन. इक्वेशन क्या दिया हुआ है? x1 प्लस 2x2 माइनस x3, 3x1 माइनस x2 प्लस x3. x1, x2, x3 अननोन्स है ना?
ठीक है सर.
तो कितने अननोन्स हैं उसमें?
3
तो बस 3 है.
x1 x2 x3.
हाँ,
ठीक है सर.
हाँ वही अननोन्स. ठीक है, यहां तक सबके समझ में आ गया? आया या नहीं आया?
Yes, sir. Okay.
आ गया. ओके. तो अब हम देखते हैं कि एक मेथड है. अब हमको इसको सॉल्व करना है. अब यूनिक सॉल्यूशन है, तो लेट अस फाइंड आउट व्हाट विल बी द सॉल्यूशन. ओके, व्हाट विल बी दैट सॉल्यूशन. हमारे पास जो मैट्रिक्स सी आया था, वो मैट्रिक्स क्या था? 1 2 -1 3. ठीक है. 0 -7 5 -8 0 0 5 20 and 0 0 0 0. ठीक है. Is it okay?
Yes, sir.
All right. So this system of equations can be written like this. So system of equations can be written like this. x1 plus 2x2 minus x3 is equal to 3 minus 7x2 plus 5x3 is equal to minus 8 and 5x3 is equal to 20. Can we write down it like this? Can we write down like this?
Yes, sir.
Okay. All right. Now,
Yes.
now, in fact, I can write on one more this thing, that this whole thing can be written like this also. C dash x is equal to b. Okay, where b is this one and c dash is equal to this one. Okay, and x is equal to, so c dash is equal to 1 2 minus 1 0 minus 7 5 and 0 0 5, right? And x can be written like this: x1 x2 x3. यदि x y z है तो x y z आ जाएगा, इक्वल टू b. b is this one, 3 minus 8 20. ठीक है? Is it okay? So
Yes, sir.
this whole thing can be written in this form, or in fact the system of equations can be written in this form: ax equal to b kind of thing. ठीक है? Understood?
Yes, sir.
Yes, sir.
हाँ. So from this actually I'll get this. Now if I solve this, तो x3 is equal to 4. ठीक है? If I put back in this equation, then what I will get? Minus 7x2 plus 5 into 4 is equal to minus 8. So minus 7x2 is equal to minus 28. So x2 is equal to 4. All right. And then once we have got these two things, then we can put back it into this one. So x1 plus 2 into x2 is 4 minus x3 is 4 is equal to 3. So from this, x1 is equal to 1. Am I right? Or minus 1 rather. Okay?
Yes, sir.
So what is the solution? What is the solution of this equation? Minus 1,
-1, 4.
4, 4. You can put back in those equations and you can see that all those equations are satisfied by this solution. And this is unique solution. Only single solution is available for this particular set of equation, and that is this one. I hope it is clear to you all.
Yes, sir.
Yes,
All
sir.
right.
Yes, sir.
Huh? Understood na?
Yes, sir.
Now,
Yes, sir.
this method of solution of set of linear equations is known as Gauss elimination method. What it is known as? It is known as Gauss elimination method. ठीक है? Understood?
Yes, sir.
So in this method, what do we do? Okay, let me once again briefly tell you. So in Gauss elimination method, there are two steps. One is that we have to convert the matrix in upper triangular matrix or in echelon form. ठीक है ना? Number one thing we have to do this. That this upper in a matrix has to be converted into first step 1. So what will we do? That if we have been given system of equations a11x1, a12x2 and so on, plus a1n equal to b1, a21x1 plus a22x2 and so on and so forth, a2n 2 into xn is equal to b2 and like that. Okay, so what we will do, first of all, we will convert it into a12 1n and let us say b. Okay, then from this we will remove all the zeros below, means all these elements below, that is we will put it into zero form. Only this will be there and these all will become 0. Next, this is a22, okay, and in fact if I change it, then it will be a22 dash, a2n dash, b2 dash, because I have to do some operation, isn't it, in order to remove it? Right or wrong?
Yes, sir.
So row operation I will do, so I will change it. So likewise, then next what I will do, that I will remove all the all the elements from here, so all will be 0. Next time same way I will continue, so like that I will continue. So in the last row, what I will be left with, say this will be a-n-n dash, and let us say this is bn dash. ठीक है? I have written dash ना, इसको n लिख देते हैं, इसको ऐसा कुछ है ना, or n minus 1, whatever it will be. So the thing is that we will do this operation. So we will make all coefficients 0. जैसे first में ये पिवोट एलिमेंट के नीचे, फिर पिवोट एलिमेंट के नीचे, नेक्स्ट में फिर पिवोट एलिमेंट के नीचे, like that we will continue until all are becoming zero except diagonal elements and these elements. ठीक है? Understood?
Yes, sir.
Okay. Now what we will do, that we will now back substitute. So from this I can find out the value of xn. Is it or not? bn by ann. ठीक है? Is it okay? Is it okay? From
Yes,
this
sir.
I can find out this. Now what I will do, I will back substitute. So इसको हम xn की वैल्यू से हम xn minus 1 निकालेंगे, देन उसके ऊपर वाले इक्वेशन में हम सब्स्टिट्यूट करेंगे, तो देन वी विल फाइंड आउट xn minus 2. Like that we will continue till the first equation, and the first equation will give us x1. So from that x1, x2, x3, xn minus 2, xn minus 1, xn, these values, these unknowns we will find out. I hope you understood.
Yes, sir.
Understood na?
Yes, sir.
All right. So this is what it is. This is called Gauss elimination. So there, this is step number 1, and step number 2 is that back substitution. So first step is elimination below elimination of elements below pivot element in that row, and then or we have to convert into echelon form, whatever you want to say, or and then second thing we have to do back substitution, and this is what exactly we did in this particular problem in order to solve it. I hope you understood this method. समझ में आ गया सबको?
Yes, sir.
आ गया ना?
Yes, sir.
Yeah. So that is what we have to do it. So this is called Gauss elimination method. Anybody who couldn't understand? Anybody who couldn't understand?
Sir, we have to make the matrix in echelon form.
And
Sir,
then
but in echelon form, the pivot points should be 1. Sir,
no,
like
no, that's okay. Actually, that is actually 1 is not necessary. And if you want to make it 1, we can definitely divide it by something. Okay.
yes, sir.
I hope you understood what I want to say.
Yes,
so it is
sir.
same thing. You multiply by that much amount or divide
Sir,
it by that.
sir, then the equations will change.
Why?
Sir, like we got matrix.
So it will be actually divided everywhere, na?
Yes, sir, understood.
So ultimately it will be
Sir,
actually the denominator will once again
yes,
cancel
sir.
each other.
Yes, sir,
So
understood.
it will remain same. I think it is okay.
Yes, sir.
So now we have been given a problem. 2a plus 4b plus 3c plus d is equal to 15, or 3a plus 7b plus 2d is equal to 16, and 5a plus 3b plus 2c plus 3d is equal to 21. All right. This is the system. So now first of all, we have to examine the consistency. What we have to do? Examine the consistency means we have to check whether it is consistent or not. So what we do? And if it is consistent, then we have to solve with the help of Gauss elimination method. I have already described Gauss elimination method. How do we do it? So यहाँ पर कितने unknowns हैं? A, B, C, D. How many unknowns are there? 4. How many equations are there? 3. Okay. Chalo. So what is the coefficient matrix? 2, 4, 3, 1. 3, 7, 2,
7, 0.
9. 0, 7 actually, na?
0, 2.
0, 2, sorry. 3, 7, 0, 2. And then we have 5, 3, 2, 3. Is it okay? And B is,
Yes.
the augmented matrix is 2, 4, 3, 1, 15. 3, 7, 0, 2, 16, and 5, 3, 2, 3, 21. Is it okay?
Yes.
Yes, sir.
So now our first aim is what? First aim is to convert this augmented matrix into echelon form. I told you. So let us bring it to that. So how do we do? By row operations. So let us do it. So R2 minus 3 by 2 R1 and R3 minus 5 by 2 R1. So by doing so, what we will get? We will get 2 2, 4, 3, 1, 15. ठीक है? 0, 1, 9 by 2, 1 by 2, minus 13 by 2, and 0 minus 7, minus 11 by 2, 1 by 2, and minus 33 by 2. ठीक है? Right? This is, we will get, then next what we will do, तो ये तो हमने 0 बना दिया, right? Right? Now next is कि 2 R2 and 2 R3. So we can write down 2, 4, 3, 1 and 15. 0, 2, minus 9, 1, minus 13, and 0, minus 14, minus 11, 1, minus 33. तो हमने ये 2 को हटाने के लिए हमने इसको 2 से मल्टीप्लाई कर दिया. कर सकते हैं ना हम?
Yes, sir.
ठीक है ना? हम कर सकते हैं क्योंकि हमने दोनों तरफ किया है, लेफ्ट हैंड साइड में भी और राइट हैंड साइड में भी. दैट इज ऑलवेज अलाउड, वी कैन डू इट. Now next is R3 plus 7 R2. So what we will get? 2, 4, 3, 1, 15, 0, 2, minus 9, 1, minus 13, 0, 0, minus 74, 8, minus 124. ठीक है? All right. This is echelon form.
Yes, sir.
Once we have achieved this echelon form, then we try to find out rank. How many non-zero terms are there? 3.
3, sir.
So it means rank of C, this is equal to C. So rank of C is equal to, means C matrix. So rank of C is equal to 3. So the same should be the rank of B also. ठीक है ना? Rank of B should also be 3.
Yes, sir.
All right. Now we have to remove this. Huh? So if I remove from the column, then I'll get 2, 4, 3, 1, 0, 2, minus 9, 1, 0, 0, 7, minus 74, 8. ठीक है ना? ये है D matrix, right? After removal of this last column. ठीक है? Is it okay?
Yes, sir.
All right. So now, what will the rank of D?
3, sir.
All right. So rank of D is also 3. So what should be the rank of A?
3.
Correct. So rank of A should also be 3. ठीक है ना? तो rank of A is equal to rank of B. Isn't it? Both are 3. Both are 3, na?
Yes,
Yes,
sir.
sir.
So it means the system should be
Unix.
consistent.
Contiguous.
It should be consistent.
Yes, sir.
Okay, and it has solution. If it is consistent, means it has at least one solution. It may have more than one solution, right? Now next, what we see over here. Next, what we see over here, that rank of A,
Rank of A is less than number of
of unknowns, because unknowns are 4, rank is 3. Is that, isn't it?
Yes, sir.
So it means it has
Many solutions.
many solutions. Correct. It has many solutions. ठीक है ना?
Yes, sir.
It has many solutions. So now if I look at this C matrix, that C matrix can be written as 2A plus 4B plus 3C plus D is equal to 15. 2B minus 9C plus D is equal to minus 13, and minus 74 C plus 8D is equal to minus 124. Can I write down it like this?
Yes, sir.
Right? यहाँ तक तो सबको समझ में आ गया ना?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so from that matrix only I have written. अच्छा, यहाँ तक मैं लिख चुका हूँ. तो now D will be equal to what? अब हम Gauss elimination method लगाते हैं. Gauss elimination method में what we are doing? This value, from this value, whatever value we get of D, we will put back in this. From that we will get value of C, and then from that we will get value of B and A, right? Like that we continue. So D is equal to 74C minus 124 by 8. ठीक है ना? जिसको हम ऐसे भी लिख सकते हैं 37C minus 62 by 4. We have divided it by 2. ठीक है ना? Right?
Yes, sir.
तो यहां से अब B भी निकल जाएगा हमारा. इसमें यदि हम पुट करेंगे तो C तो आ ही रहा है, C के टर्म्स में ये, तो B आ जाएगा हमारे पास 10 minus C by 8. ठीक है? सॉल्व करके देख सकते हो तुम लोग. 2b minus 9c plus 37c minus 62 by 4 equal to minus 13. इसको solve करके देखो, you will get this. I hope it is clear.
Yes, sir.
So once we have got this, then now finally we have to put back it into equation number 1. So from that actually we will get A is equal to 102 minus 47c by 8. ठीक है ना? तो क्या हमारे पास सॉल्यूशन क्या मिला है हमको? 102 minus 47c by 8, 10 minus c by 8 and 37c minus 62 by 4. Okay, these are the solutions. यही है ना सॉल्यूशन?
Yes, sir.
All right. And of course we will get C also, है ना? C भी तो एक solution है ना? So these are the solutions actually we have got. Now C can take any real value. अभी तो हमको पता नहीं C की वैल्यू क्या है. C can take any real value. हम तो निकाल ही नहीं पाए ना C की वैल्यू. नहीं निकाल सकते ना हम. Understood? Can we find out?
Yes, sir.
We cannot
No,
find
sir.
out.
Yeah,
Right?
we can.
तो C could be anything. है ना? मान लो C 0 है. तो what will be the solution? 102 minus 102 by 8, 10 by 8, 0 and 37, sorry, minus 62 by 4. ठीक है? If C is equal to 1, then you can find out what will be the solution. And like that. So it means depending upon the value of C, its value will change. So it can have many solutions. I hope you understood.
Yes, sir.
Yeah. So this is what is all about this thing, right?
Yes, sir.
Okay, then we can. Tomorrow we will see.
Okay, sir.
Okay, okay.
Thank you.
Thank you, sir.
Thank you, sir.
Ah,
Good day, sir.
good day, good day.
Thank you, sir. Good day, sir.
Good day.